Exercise 2.3, question number 3. Here is asking to obtain all the zeros of a polynomial 3x to the power 4 plus 6x cube minus 2x square minus 10x minus 5 if two of its zeros are root of 5 by 3 and minus root of 5 by 3. So, if we notice here, this polynomial has a power 4. Degree of this polynomial is 4. Therefore, we call this as biquadratic polynomial. So, since this is biquadratic, the power of the variable is 4, we'll be having maximum 4 zeros. But in the question already given 2 zeros. So, we need to find another 2 zeros here. So, here, we know that if we have a number 6, 6 can be written as 2 into 3. Therefore, we can say that 2 is a factor of 6 and 3 is a factor of 6. And combined together, 2 into 3 is also a factor of 6. So, making use of this logic, we'll try to find the zeros for this polynomial. So, we can say that here 2 is a factor of 6. 3 is a factor of 6. So, factor means, so 2 divides 6 and 3 divides 6. Therefore, 2 into 3, the product of these two factors also divides 6. Is also a factor of 6. So, making use of this logic, so let us find the zeros of our given polynomial. So, in the question already given that this is one factor, or this is 1 0 and this is 1 0. So, either we say zeros or we say factors or we say roots, all three are one and the same. So, first we'll consider the given polynomial as p of x. So, p of x is 3x to the power of 4 plus 6x cube minus 2x square minus 10x minus 5. So, given in the question that this root of 5 by 3 is a 0. Therefore, one of the root of this polynomial is x is equal to root of 5 by 3. So, when we find the value of x, we'll get one of the value of x as root 5 by 3. And we'll get one more value of x, that is minus root of 5 by 3. So, given in the question, this is a 0. Is a 0. Now, so if this is a 0, so for the simplification purpose, we'll take this root of 5 by 3 to the LHS and this minus root of 5 by 3 to the LHS. So, we can write x plus root of 5 by 3 will be converted to minus root of 5 by 3. So, now this is a factor, or we can call this is a 0 also. Since here we are making use of a word factor, so we'll call that x minus root of 5 by 3 is a factor. And here minus root of 5 by 3 will be converted to plus root of 5 by 3 is a factor. Now, we got two factors here. Like here, we got two factors, that is 2 and 3 are the factors of 6. Similarly, we got x minus 5 by 3 and x plus 5 by 3 is a factor of our given polynomial. Now, therefore, we can say that product of these two, so product of these two numbers is also a factor of 6. Similarly, product of these two number, or we'll say product of these two terms is also a factor of our polynomial p of x. So, let us write that. Therefore, x minus root of 5 by 3 into x plus root of 5 by 3 is also a factor of p of x. Now, if we notice here, this is of the form a minus b into a plus b. A minus b into a plus b is written as a square minus b square. Now, so in the place of a, we have x. So, if we notice here, in the place of a, we have x. And in the place of b, we have root of 5 by 3. So, in the place of b, we have root of 5 by 3. Therefore, this can be written as a square minus b square. So a square minus b square will be x square minus root of 5 by 3 whole square. So further we can simplify this. Here root and square and root will get cancelled. We are left out with x square minus 5 by 3. Therefore now this is a factor of our polynomial. If this is a factor, then this polynomial or this term will divide our p of x. So minus 5. So we got this one is a factor. Therefore we divide p of x by x square minus 5 by 3 to find the other factor. Other factors. Now, so first we'll consider our p of x. So let us consider p of x here. So our p of x given in the question is 3x to the power of 4 plus 6x cube minus 2x square minus 10x minus 5. And we have to divide by x square minus 5 by 3. So to divide this, first we'll consider the first term of our p of x and the first term of our g of x. And we'll divide this 3x to the power of 4 divided by x square. So here x square term and x square term will get cancelled. We are left out with 3x square. Now we'll write this 3x square in the quotient place and we'll multiply with the g of x. So let us multiply 3x square into x square is 3x to the power of 4. Now next we'll multiply this 3x square into minus 5 by 3. Minus 5 by 3. If we notice here, this 3 and this 3 will get cancelled. We are left out with minus 5x square. So wherever x square term is there, we'll write below that. We'll get minus 5x square. Now let us subtract this. So before we subtract, we'll change the sign. So plus 3x to the power of 4 will change to minus. And here plus minus 5x square term will change to plus 5x square. So 3x to the power of 4 and minus 3x to the power of 4 terms will get cancelled. Now there is no cube term to solve. So we'll just take this cube term as it is. That is 6x cube. Then we have minus 2 and plus 5. Minus 2 plus 5 is plus 3. And this x square term we will keep that as it is. Now minus 10x and minus 5. Now next. So here we'll consider the first term of our p of x and the first term of our g of x and we'll divide. That is 6x cube divided by x square. So here x square term and x square term will get cancelled. We are just left out with 1x and here we'll be getting 6 into x. So this 6x we'll write here. We got plus 6x, so we'll write plus 6x here and this plus 6x will multiply with our g of x and we'll write it here. So 6x into x square, if we multiply, we'll get 6x cube. And 6x, so here we have 6x into minus 5 by 3. So we'll be getting 3 ones are 3 and 3 twos are is 6. So we can divide this. Now we'll be getting 2 into. So 2 into minus 5 is minus 10. So minus 10 and here we have x minus 10x. So we'll write minus 10x below the x term. So now let us subtract this. So before we subtract, we'll change the sign. Plus will change to minus and minus will change to plus. So here 6x cube and minus 6x cube will get cancelled. We don't have x square term, so we'll keep this as it is 3x square. And here minus 10x and plus 10x will get cancelled. Now we are left out with minus 5. So next. So again we'll consider the first term here in p of x and first term here in g of x and we'll divide that. That is 3x square divided by x square. So if we notice here x square term and x square term will get cancelled. We got 3 and that 3 will write it here, that is plus 3, and this plus 3 will multiply with our g of x and we'll write it here. So 3 into x square is 3x square and then we have 3 into minus 5 by 3. So here 3 and 3 will get cancelled. We are left out with minus 5. That minus 5 we will write it here. Now let us subtract this. So before we subtract, we'll change the sign. So plus will change to minus and minus will change to plus. 3x square and minus 3x square terms will get cancelled. Minus 5 and plus 5 terms will get cancelled. And we are left out with 0. Here the remainder is 0. So after dividing, we got the quotient here. If we notice here, we got the quotient. So this was our P of x. This was our G of x. And this is our quotient. And this is our remainder. So we got 0 because here we have said that this is a factor of our polynomial P of x. Since this was a factor, we got 0 when we divided, or else we would have not got 0 here. Now let us consider the quotient term and we'll factorize. So here, let us factorize the quotient. So if we notice here, we have 3x square plus 6x plus 3. So this is a quadratic polynomial. So quadratic polynomial can be solved using splitting the middle term method. So this is a very easy method. Now we'll split this middle term in such a way that its sum should be plus 6 and its product should be. So sum should be plus 6 and our product should be 3 into 3. So we'll multiply 3 into 3 and that is 9. So let us split this 9 in such a way that its sum should be 6. So this can be written as 3 into 3 and if we add we'll get 6. Therefore 6x can be written as plus 3x and plus 3x. So 6x we have split it as 3x and 3x in such a way that when we add we'll get 6 here plus 3. So here in our first two terms, if we notice here, 3 is a common, 3x is a common here. So we'll take out 3x common. We'll be left out with x plus 1. And here if we notice in these two terms, 3 is a common. So we'll be left out with x plus 1. So in both the terms, x plus 1 is a common. So x plus 1 if we take common, we'll be left out with 3x plus 3. Now, so we equate to 0 to find the value of x. To find the value of x. So x plus 1 and 3x plus 3 is equal to 0. So since this is a polynomial, so to find the roots or the zeros of this polynomial will equate to 0. Now x plus 1 is equal to 0 and 3x plus 3 is equal to 0. So let us simplify here. We need to find the value of x. So we'll send plus x to the RHS. We'll get x is equal to plus 1 will be converted to minus 1. And here 3x will send this plus 3 to the RHS. We'll get minus 3. Then we need x. So we'll send this 3 to the RHS. So x is equal to minus 3 by 3. So here 3 and 3 will get cancelled. We got the value of x is equal to minus 1. Therefore, we can say that x is equal to minus 1 and x is equal to minus 1. So both the roots are minus 1 here. We'll say that is a zeros of our given p of x. Therefore, finally we can conclude that the zeros of p of x are root of 5 by 3, root of 5 by 3, minus root of 5 by 3. These two zeros had already given in the question. Now we have found the other two new zeros here, that is minus 1 and minus 1. So this is our final solution.